Let's take a look at how to factor a polynomial. So in this example, anytime you have a polynomial where the leading coefficient, so the coefficient in front of that x squared term, is 1, there are some simple steps that you can follow to factor this polynomial. So we want to break down this polynomial into two factors, where when I multiply those factors back together, it'll give me back x squared plus 8x plus 16. So to do this, we're going to focus on the first term. So the first term here is x squared, where the leading coefficient is 1. So we can factor that out as x times x. So what you do is you write that down as one term in the first factor and then a term in the second factor. Okay, the next thing that we're going to do is we're going to take a look at the last term. So that's 16, this constant 16. When we are trying to factor this polynomial, our goal is to look for, let me use my pen here instead of my highlighter. We're looking for two numbers, okay, where when we multiply them together, they give us the product 16. So to do that, we want to list all the factors of 16. So let's list the factors of 16. Those are 1 times 16, that gives me 16, 2 times 8, and 4 times 4. So those are the factors of 16. And then the next thing that we want to do is we want to take a look at the middle term, or the coefficient of the middle term, so that 8. And when we are looking at the factors of 16, we also want to consider which factors of 16 will give us a sum that equals 8. So if we take a look at all the factors of 16, 1 plus 16 does not equal 8, so we don't want to use those factors. 2 plus 8 does not equal 8, so we don't want to use 2 and 8. But notice that 4 plus 4 equals 8, so we're going to use 4 and 4. And so to write this, we would say x plus 4 times x plus 4. And then you can always check your answer by foiling. So you can FOIL and check that x plus 4 times x plus 4 does equal out to x squared plus 8x plus 16. Okay? All right, let's take a look at another example. Let's take a look at another example. So here we have another trinomial where the leading coefficient is 1. And let's try and factor this polynomial. So let's go ahead and write out our two factor pairs here. And we are focusing on the last term, 28, and the coefficient of the middle term. So we are looking for the factors of 28. So what numbers, when we multiply them together, give us a product of 28. But when we add them, so when we add the factors of 28, it gives us a sum of 11. So let's start listing the factors of 28. That's 1 and 28. But we know that 1 plus 28 does not equal 11, so we can go ahead and eliminate that. Another factor pair for 28 is 2 and 14. But 2 plus 14 does not equal 11, so we can eliminate that factor pair. And then another factor pair for 28 is 4 times 7. So 4 times 7 gives us 28, and 4 plus 7 does equal 11. So this is the factor pair that we want to use. So let's go ahead and write this down. So for x squared, we can break that down as x times x. And then here, because we've got plus and plus, this would be plus 4 and plus 7. So again, you can check, use the foiling method to check to make sure that x plus 4 times x plus 7 does equal back up to x squared plus 11x plus 28. All right, a few more examples. Okay, here's another example, but in this example, notice that we have x squared plus 4x and then minus 5. So we've got a minus sign here in that last term. But again, the leading coefficient here is 1, so we can factor this out by breaking this down into two factor pairs. And just as before, what we're going to do is focus on that last term, negative 5, and the coefficient of that middle term, 4. So I'm looking for, oops, let me use my pen here. So we're looking for the factors of negative 5. So what two numbers, when we multiply them together, give us negative 5? But when we add them, gives us a sum of positive 4. So if we list factors of 5, since 5 is a prime number, the only factors are 1 times 5. But now here we have to consider the sign. So we know that if we multiply positive 1 times positive 5, that gives us positive 5. And we want a product of negative 5. So that means either the 1 has to be a negative or that 5 has to be a negative. So which factor you assign that negative sign to depends on the sum. So notice here we're looking for a sum that's positive 4. So to get that positive 4, we would want to make the 1 a negative and then make that 5 a positive 5. So then negative 1 plus positive 5 gives us negative 5, but negative 1 plus 5, right, equals 4. So those are the factor pairs that we're going to use. So x squared, we can break that down as x times x. And then here, we would use that negative 1 and positive 5. And so here, to factor x squared plus 4x minus 5, that gives us x minus 1 times the quantity x plus 5. All right, a few more examples. Let's keep going. Let's take a look at this example. We've got x squared minus 5x minus 14. So again, notice that this trinomial has a leading coefficient of 1. So we want to factor this polynomial. Let's go ahead and break it down to two factor pairs. This first factor will start off with x and x, because x times x is x squared. And then just like before, we're going to take a look at the last term, which is negative 14, and the coefficient of the middle term, which is negative 5. So our goal is to try to find the factor pairs of negative 14. So what two numbers, when we multiply them together, give us a product of negative 14, but when we add those numbers together, it gives us a sum of negative 5. So let's break down negative 14 into some of its factor pairs. So 1 times 14 and 2 times 7. But right now these are all positive numbers, so that's not going to give me a negative 14. So what I need to do is I need to make either the 1 a negative, or a 14 a negative, or a 2 a negative, or a 7 a negative. Now we can go ahead and eliminate the first factor pair 1 and 14 because there's no way that I can add those numbers in any way to get a sum of negative 5. But if we take a look at 2 and 7, if I make 2 positive and 7 negative, then when I multiply positive 2 and negative 7, that will give me negative 14. And then when I add them, so positive 2 plus negative 7, that will add up to negative 5. So that's the one that I want. So here I would write that down as negative 7, x minus 7, times x plus 2. So that's how we would factor out that polynomial. Okay, let's take a look at a few more examples. All right, let's take a look at this polynomial. Now this one's a little different from the other two. This is a special type of polynomial. This one is an example of what we call the difference, okay, of two squares. So anytime you have a polynomial that is the difference of two squares, so here difference meaning we've got that subtraction sign, and two squares because the first term here, we've got 9x squared. So 9, if we take the square root of that, that's 3 squared, and then x squared is a squared number. And then the second term here, 25, that is also we can take the square root of 25. That's 5 squared. So notice you have the difference of two different squared numbers, 3 squared and 5 squared. So how do we deal with factoring the difference of two squares? And the way we would factor this is to simply break it down as 3, okay, x plus, and then 3x minus, okay? So the 3x comes from the square root of 9. So the square root of 9 is 3, and then the square, so let me write this down. The square root of 9 is 3, and then the square root of x squared is x. So when we take the square root of the first term, we write it down as 3x. And then because it's a minus sign, we're going to do a plus and a minus in the factor pair. And then you take the square root of 25. So you say, okay, square root of 25 is 5. So then we write that as a part of the factor. So here, if you FOIL this back up, let me just FOIL this back up, you'll see that when we multiply these terms back together, it'll give you 9x squared minus 25 again. So let's recall how to FOIL. So here I would take a look at the first term. Okay, so 3x times 3x is 9x squared. And then I would take a look at the first term and this last term here. So that's 3x times negative 5, which is negative 15x. And then if we take a look at the inner terms here, 5 times 3x is positive 15x. And then let's take a look at 5 times negative 5, which is negative 25. So notice here the two terms in the center cancel out, leaving us with 9x squared minus 25. So that's how we would factor the difference of two squares. Okay? All right, let's do another example. Here, hopefully you can see that this is another difference of two squares. So if I take the square root of x squared, that's x. And if I take the square root of 4, that's 2. So we know that 2 squared is 4 and x squared is x squared. So here we have a difference of two squares. So we can write this down as plus and minus. And then just take the square root of that x squared term, that's x. And take the square root of the second term, 4, which is 2. So this is going to be x plus 2 and x minus 2. So that's how we would factor that out. Okay.